In the last video, we showed that when we solve initial value problems of nth order linear differential equations, that as long as we satisfy a few continuity requirements and one other requirement, that the solutions to the initial value problems exist and are unique, meaning there are no other solutions that satisfy those conditions. This does not hold for boundary value problems. And recall that the difference between a boundary value problem and an initial value problem is that the boundary conditions, they take place at two separate inputs of x. So we might have y of x sub 0 is equal to y sub 1, and y of x sub 1 is equal to, or rather this is x sub 0, and y of x sub 1 is equal to y sub 1. So what this might look like in practice, if we had some sort of practice example, that we might have y of 0 is equal to 1, and we might have y of pi is equal to 3. And here our boundary, we would have a boundary from 0 to pi. So we would have 0, and then we would have pi, and we would be computing or rather finding the solution over this boundary. Whereas the initial value problems, all of the initial conditions were at one point, either 0 or pi or whatever other point we decided. So boundary value problems, they aren't always unique, and what we'll find is that they fall into three different categories. So the first category is one solution. The second is infinite solutions, so infinite solutions, and the third is none. We'll have no solutions. So let's look at an example that will help us to understand this. So we'll have the differential equation y double prime plus y is equal to 0, and it can be shown that the solution to this differential equation is of the following form. So c1 cosine of x, and then plus c2 sine of x. And if you want, just as an exercise, you could find the second derivative of this, and then you could add it to just this right here, and you would find that that equals 0. So what we'll do is we'll have three different categories. The first one, we're going to have the initial conditions where y, or the boundary conditions of y of 0 is equal to 0 and y of pi over 4 is equal to 0. So here we have the boundary from 0 to pi over 4. Now in the second example, we will have y of 0 is equal to 0, and we will have y of pi is equal to 0. So now our boundary will be from 0 to pi. And in the third example, we will have y of 0 is equal to 0, and y of pi is equal to 10. Okay, so let's try to solve each one of these, and we already have the solution to the equation. We just need to specify what the constants need to be in order to satisfy the boundaries. So y of 0 is equal to 0. We have 0 is equal to c1 times cosine of 0 plus c2 sine of 0. So what happens now is we have 0 is equal to, well, cosine of 0 is 1, so this is equal to c1 plus, well, sine of 0 is equal to 0, so that's just 0. And this implies that c1 is equal to 0. Well, if c1 equals 0, then our solution will be of this form right here. And now if we apply the second condition, then we'll have 0 is equal to c2 times sine of pi over 4. Now sine of pi over 4 is equal to the square root of 2 over 2. So 0 is equal to c2 root 2 over 2. And I will ask you, for what inputs of c2 is this actually equivalent? And the answer is the only input that makes this equivalent is c2 is equal to 0. Which means that both c1 and c2 are equal to 0, and our solution is unique, and it's y equals 0. So that is the case where we have one solution. Okay, now let's look at the next one. Well, here we still have y of 0 is equal to 0, so we can assume that c1 is equal to 0, which means that y is equal to c2 sine of x. Now, if we compute the second boundary condition, then we have 0 is equal to C2 sine of pi. Well, sine of pi is equal to 0. So now we have 0 is equal to C2 times 0. And I'll ask you the question once again. For what inputs of C2 will this equation actually be equivalent? And the answer is, well, you can plug anything into 2. You can plug any number on the entire number line, real number line, into this, and you will have in both sides of this equation will actually be equivalent. So we have an infinite number of solutions, and our solution is just generalized as y equals c2 sine of x. Okay, so now we have an infinite number of solutions, which was our second category. And lastly, we'll look at this last example. Okay, well, we once again have y of 0 is equal to 0, so we know that c1 is equal to 0, and we know that y is equal to c2 sine of x. Well, now, if we plug in the boundary condition, we have 10 is equal to c2 sine of pi. Well, sine of pi is equal to 0, which would mean that 10 is equal to 0. But this obviously is not true, and in this case, we would have no solutions, so none. Well, that was just a brief introduction to boundary value problems, and just be careful not to apply the same results for initial value problems and the promise of uniqueness and existence. Be careful not to apply that to boundary value problems because it's not always the case.